If I take a picture of a landscape, what do you expect that picture to end up looking like? Yeah, probably the actual landscape. That's kind of the point of a photograph. We expect cameras and other devices that use lenses to concentrate light to behave in a specific way. Basically, when light waves from a source pass through a lens, those waves are supposed to converge on a single point. That's how you actually see an image through a lens. But sometimes this doesn't happen. Sometimes light waves miss each other, and instead of converging, they end up at different points, resulting in an image that is blurred or distorted. We call the factors that cause light not to converge through a lens optical aberrations. Optical aberrations can occur in telescopes, microscopes, cameras, and anything else that uses simple lenses to produce an image. So how do we fix optical aberrations in a simple lens? The answer is complex. You'll get that in a minute. Now, technically, optical aberrations can occur in a number of ways. However, they can be sorted into two main categories. First are chromatic aberrations, aberrations that occur when light refracts through the lens into various wavelengths of color. Basically, think of how light is concentrated when it shines through a magnifying glass. That's what it's supposed to look like. Then think about what happens when light shines through a prism. That's sort of what happens in a chromatic aberration. Instead of converging, the light disperses as light waves of various lengths refract differently. Light wavelengths for red end up refracting at a different angle than light waves for blue, and the aberration occurs. So how do we fix it? Back in the 18th century, scientists realized that if some lenses refract red light at one angle, and some refract blue at another, by combining them, they could make both light waves converge at the same point. The result was a doublet, two lenses of different material combined together to make light of different wavelengths converge. A doublet is an example of a complex lens, a lens made from two lenses of different surface shapes that share an axis. It's a complex lens. Complex. See? Told you you'd get the joke later. Anyway, these complex lenses can be shaped in different ways to correct various chromatic aberrations and bring various waves of light back to a single converging point. The other main kind of optical aberration is called a monochromatic aberration, in which the distortion is caused by the spherical shape of the lens. Basically, some light comes through the lens at sharper angles than others, and while they don't disperse into light waves of single colors, they do fail to converge on a single point. The shape of the lens, the way the lens curves, can cause a monochromatic aberration, and so reshaping the lens is one way to attempt to fix it. We can combine simple lenses to create complex lenses that are curved in different ways, which again works to correct aberrations within a single lens. Now, if we can control light so much more efficiently just by combining two lenses into one, imagine what happens when we add new lenses entirely. Most complex tools like cameras and microscopes and telescopes rely on more than just a single lens. Instead, complex and simple lenses are stacked within a containing shaft to create the highest amount of precision and control, ensuring that light converges through a lens exactly where we need it to. When light passes through a lens, it's supposed to converge in a specific way. But this doesn't always happen. We call the factors that cause light not to converge through a lens optical aberrations. There are two main kinds. A chromatic aberration occurs when light refracts through the lens into various wavelengths of color. Basically, the white light is split up, and the red and blue waves refract at different angles, so they don't converge. This is a common problem in simple lenses, but can be fixed with a complex lens, a lens made from two lenses of different surface shapes that share an axis. In this case, we're talking about a doublet, in which two lenses of different material are combined together to make light of different wavelengths converge. The other main way light can fail to converge is from a monochromatic aberration, in which the distortion is caused by the spherical shape of the lens. Again, this can be corrected with more complex lenses. Often, multiple complex and simple lenses are compiled to create an even greater amount of control. Sometimes, it isn't so bad for things to get a bit more complex.